Hello. In this video, we are going to review the learning objectives from section 1.15, 16, and 17, which is inverse functions, direct and inverse variations. In the first two questions, we're asked to graph the inverse of each of these functions. So this is the graph of f of x, and the inverse is going to be a reflection of this thing across the line y is equal to x. So we want to reflect it across this line, which simply means that these points get flipped for every x and y that's on f of x. On the inverse, we'll have y and x. So we just simply switch the domain with the range. So let's plot these points. So let's start with plotting first the point. This point reflected across the line y equals x. So since this point is at 2, -7, then that means at -7, -2, we'll have a point on the inverse. And you know what? Let's graph it in red. Since this point, this next point here is at 1, -6, then we'll have a point at 1, -6, +1. The following point is located on the y-axis at 0, -3. So then we'll have a point on the x-axis at -3, 0. Our next point is at 1, 2. So we'll have our next point at +2, 1. And the last point we have is this one up here, which is at +2, 9, which means when I reflect it would be at +9, 2. And I missed that middle point right there. And there is our inverse. For number 2, we want to do the exact same thing. Again, we want to reflect it. Again, to draw the inverse, we want to reflect this graph across this diagonal line. So we simply switch the coordinates to every point that we see here. So starting with this point up here, this point is at -8, 8. So the inverse would be at +8, -8. The following point would be at -4, 6. So our next point would be at 6, -4. Then we have a point at 0, 4. So we'll put our next point at 4, 0. This point is located at 4, 2. So the inverse of that would be 2, 4. And the inverse of 8, 0 would be at 0, 8. So there's our inverse. Now the next thing that you need to do with it about inverses is find the inverse to a function. So let's look at example number 3. So to get the inverse of this function here, we would switch the y with the x. So remember, this is the same thing as y. So we're going to switch the x and the y, and we're going to get 1/3 y minus 2 equals to x. And we're going to solve this equation for the variable y. So here, the best procedure to make this a lot quicker would be to add 2 to both sides. And then divide by the 1/3. Since we're multiplying by 1/3, we would divide by 1/3, which in dividing by 1/3 is the equivalency of multiplying by 3. So we're going to multiply by 3. So y is equal to 3 times x plus 2. Now, if you want to simplify it and distribute it, you can do that, but 3 times x plus 2 is acceptable, and that's going to be our inverse. So our inverse is 3x plus 6. For number 4, we start by switching again the x with the y. So the square root of y plus 2 minus 1 equals to x. Here, we'll start by adding the 1, moving this to the other side. So we're going to add that 1 to both sides. We're going to now take the square root to get rid of the square root. We're going to square both sides. And then we're going to subtract 2 from both sides to get rid of the y, the 2. So y would equal to x plus 1 squared minus 2. And that's our inverse. Moving on to the next example. We'll start by switching the x and the y. So here y to the third power plus 4 instead of x to the third power plus 4 equals to x. Here we have to get rid of the exponent of 3, raising it to the power, and adding the 4. So we'll start by subtracting the 4 to both sides. And now we can get rid of the exponent of 3 by taking the cube root. And that's our inverse. The final example, we have the cube root of y minus x. I'm sorry, y minus 6, not x, y minus 6, and that equals x. And here, I want to add the 6. Before I can add the 6, however, to both sides, to get rid of it, I need to get rid of the cube root first. So I would raise both sides to that third power. And of course, since raising x to the third power, that's going to give me x cubed. Now I can add 6 to both sides. And there is my, oops, I don't know what I'm writing here. Hold on, sorry. My inverse would be x to the third power plus 6. Again, f inverse of x equals x to the third power plus 6. Let's move now back to the back side of our review. So the last section, which is 1.17, this is on inverse and direct variation and inverse variation. On the first example, we read that the voltage across a resistor is directly proportional to the current flowing through it. So that means that y is equal to k times x. Well, instead of using these generic variables of y and x, since we're referring again that the voltage is directly proportional to the current flow, we'll use those variables for the x and the y. So you will use v for y, and for x we'll use the current flowing through it. So we use capital C for the current. Now from the second sentence, we're told that the voltage of 10 ohms has a current of 2 amperes, 2 amps. So let's substitute in that. And because we're multiplying k with 2, we're going to divide both sides by that's 2 to figure out the value of k. So 10 is divided by 2, and we find that k equals 5. So now with k equal to 5, from this formula we can substitute in k with 5 And our formula that relates the voltage with the current is V equals 5 times whatever C is. And here we want to figure out the voltage now. What is the voltage across a resistor when the current is flowing through it is 5 amps. I'm sorry, 7 amps. So we're going to replace C with 7. So the voltage in this resistor is going to be 35. Let's look at example number 8. The distance traveled by an object is directly proportional to the time. So again, this means that D is equal to K times T. If the object travels 70 miles in 4 hours, so if the distance is 70, when the time is 40, we can figure out the value of K by dividing 70 by 40. 4, I'm sorry, not 44, which is 17.5. So using that value for K, we can figure out the hours an object will travel 210 miles. So we plug in 210 for the distance. 17.5 gets multiplied with the time, and we figure out again the time by dividing 210 by 17.5, which is 12. Now for number 9, the time it takes for a chemical reaction to occur varies inversely. So varies inversely does a different operation. That means that Y equals to K divided by X. So it doesn't multiply our X and our constant and X, it divides those two things. And here, since we're using the time and the concentration of the reactants, let's use T for time and C for the concentration. So if it takes 10 minutes for a chemical reaction to occur when the reacting concentration is 0.1 moles per liter, that means we have 10, the time is 10, when our concentration is 0.1. So here, to figure out the value of K, we're going to multiply 10 with 0.1, which is going to equal to a total of 1. So those two things multiply, and we get 1. So now plugging in the value of K into the initial equation that we had, we can now get that T equals to 1 divided by the concentration. And now we can figure out the chemical reaction to occur, the time it takes for a chemical reaction to occur when the concentration is 0.2. And that's going to be 5. So it takes 5 minutes for the reaction to occur with a higher concentration. And the last one, the torque required to turn a shaft is inversely proportional to the radius. So the torque is inversely proportional to the radius. So let's use T for torque and R for radius. And from the second sentence, that a torque of 9 Newton meters is required to turn a shaft with a radius of 2. So 5 equals to K over 2. And I'm assuming this is Newton meters and M. I could be wrong in the unit, but anyways. Here we would multiply the 5 and 2, and the value of K would be 10. So T is equal to 10 divided by R. And now with that formula, we can figure out how much torque is required, when the shaft has a radius of 8. So let's substitute in 8 for R and divide 10 by that 8. And our answer equals 1.25. So we'll need that much torque. And there's your answer. Well, that concludes again our review. If you have any questions, send me a message or remind or an email. Again, I appreciate you watching and I hope you have a great day.